All right, so welcome back. Maybe you took yourself a little break. Maybe had a little bit of dinner, a snack or something. That's fine. That's fine. I understand. Okay, so on objective 2 on this lesson, what we're doing is we're trying to figure out how to approximate a square root without having to use a calculator. So some square roots are they're integers, like the square root of 4 is 2, and it reduces to 2, which is an integer. There was just my phone. And anyway, but lots and lots of square roots are not. Like, what about the square root of 3? Square root of 3 is not a rational number. It's an irrational number. And like, how are you supposed to write that? Okay, so here's a foxtrot cartoon, and in it, he's going, do you get the sense that playing football is irrational? And the response is, hut square root 2, hut square root 3. Very nerdy, very nerdy. Okay, so probably when you were in geometry, you had a discussion about the difference between an exact versus an approximate number. And you probably did it around the time, maybe you talked about square roots, but usually it's a in-depth conversation you have whenever you talk about pi, right? And maybe you did some sort of project on, like, where does pi come from besides the oven and like Walmart bakery. But when you write down the symbol, you have just written the exact number for pi. But whenever you write down something like 3.14158, you have just approximated it because you've stopped someplace, right? And that's the essential difference here. Whenever we're talking about irrational numbers, we're either writing something exact, like the square root of 2, and it's just the symbol for it. That's what the number is. That's usually the one that math teachers and mathematicians really, really like because, look, it's really small to write, and it's exact. It's very precise. But, like, hey, I'm going to go into a store, and I'm going to try to go buy some wood, and I'm going to buy a wood that's the square root of 2 feet long or something. That I'm not going to find that on a tape measure. So I'm going to have to approximate it. And so the approximation here is 1.412 something something something, and notice that there's that ellipse at the end, which indicates that I have to chop the decimal off someplace, and if I stop the decimal, I've just approximated the number, right? Because those things go on forever. The definition of rational was that the decimal either stopped or it was the same repeating pattern. The opposite of that for irrational is that it never stops and it never repeats. So if I have to stop at someplace, I've just approximated it, okay? And so our question is, like, how do we do that for, like, if I want the square root of 7, which is what this question is asking, I'd probably just go to the calculator and I'd type it in and I'd hit enter and I wouldn't think about it too much. But, you know, somebody had to put that in there. Somebody had to figure it out some kind of way. Now, what I'm about to show you is not how they would have programmed it into the calculator, but it's a very handy way to approximate this without too much trouble, without having to use a calculator at all, okay? So the first thing is like you got the square root of 7. It's kind of understanding what the heck the square root of 7 means. Square root of 7 just means this. It means I take a number, let's call it, I don't know what it is, so I'll just call it x. And I square it, and I multiply it times itself, and I get 7. So most people go, oh, it's a number times itself that gives you 7, right? That's exactly what we're talking about with the square root of 7. Okay, and you know that there's not a whole number that does this, because if you think of, say, 2 squared would be 4, that's too small, but then you go, well, 3 squared is 9, and then that's too big, and, well, 7's between those two things. And so most people can go, oh, I know that it's bigger than 2, but smaller than 3. And that's pretty good. But we're going to get at least one more decimal place of accuracy, okay? So, and so really this is like, this thing is in between. It is in between the square root of 4 and the square root of 9, right? It's in between those two things. So on Geometry Sketchpad, I kind of have this mapped out. Let's see if we can make a conjecture. Remember from geometry conjecture, you see a pattern, like you look at a whole bunch of cases and then you draw some sort of general conclusion about it. That's what we're going to do. Take a look.
All right, hey, a bit of a wardrobe change and perhaps a sunburn, but yeah, that's what happens when you film things out of order. Anyway, so in this sketchpad demo, what I've done is I've just made myself a number line here. It's pretty spread out because right there's the number 1. And so let me just click the button for the perfect squares. Of course, we got, square root of 1, which is 1, square root of 4, 2, square root 9, 3, and so on. Okay, so what we're trying to do is we're trying to come up with a conjecture so that we can figure out like how to easily approximate these square roots without having a calculator. So let me just take this interval from the square root of 1 to the square root of 3. Let's just think, or square root of 4. We're missing the square root of 2 and the square root of 3, right? So let me just divide that up into thirds there. So if those things were evenly dispersed in there, that's exactly where they would be in those 2 green dots, because that's 1/3, that's 2/3, and then 3/3, right? But let's see where actually the square root of 2 is. Well, it's not quite on there. Square root of 3, also not quite on there. Why not? Because remember, these things are not rational numbers. They can't be written as fractions. Okay, so now let's look at the interval from 4, well, square root of 4 to the square root of 9. So here we're missing square root of 5, 6, 7, and 8. That's 4 more. If you include that the square root of 9 in there, that's actually dividing this thing up into fifths. 1/5, 2/5, 3/5, 4/5, 5/5. Okay, and that's if they're all evenly spaced, those green ones. So let's see what it looks like where the square root of 5 is. So there it is. It's pretty close to the dot. How about the square root of 6? A little bit further away. Square root of 7. Square root of 8. Ooh, it's pretty close still. Okay, so maybe you're seeing the point here. Let me scooch on over and keep on going. Let's do the same thing between the interval from the square root of 9 to the square root of 16. So here we're missing square root of 10, 11, 12, 13, 14, 15. And if I add the square root of 16 in there, we're dividing that into 7. So perfectly spaced green dots right there. So let's see where each of those square roots are. Square root 10, 11, 12, 13, 14, and 15. You can see that those are pretty close to each other, right? Let's do this one more time, and that's the interval from the square root of 16 to the square root of 25. Divide this time up to 9. So if I subtract 25 from 16, I get 9. So 9 equally spaced dots, and show where the actual roots are. And so our conjecture, can you see this? That if I'm going to approximate it, all I have to do is divide it up into however many square roots between 2 perfect squares that I'm missing, and then count that up as a fraction. So for example, between the square root of 4 and the square root of 9, 9 minus 4 is 5. So I could divide that interval up into fifths. And the square root of 5 would just be 1/5. 6 would be 2/5. 7 would be 3/5. 8 would be 4/5. Now, you have to realize this is just an approximation. It's not exactly what it is, because if that was true, then these things would be rational numbers, and that'd be crazy.
Okay, so let's see if we can apply this then to the square root of 7, just starting fresh. So 2 things that you got to do. First of all, you want to find between what 2 perfect squares the square root of 7 is, and we know we talked about that already. It's in between. Oh yeah, let's put this on the number line. Yeah, that makes that look sweet. It's in between 2 and 3, so that's the square root of 4 and the square root of 9, in between 2 and 3. All right, so we have essentially we have the whole number part. We've just approximated it. Now we're going to improve our estimation. Okay, so that's the second part, and that's to find the units of the fractions. Remember what we discovered from that is that each of the square roots takes the interval in between the perfect squares and divides it up. Doesn't divide it up equally, but it's approximately so. So that's what we have to do. In between the square root of 4 and the square root of 9, how many units are there? So I have a little picture there. Right. So how many units are there? How many intervals are we breaking that up into? And there's 5, right? We have the square root of 5, 6, square root of 5, 6, 7, 8, and 9. So we're breaking it up into fifths. And you can see that right down there in the little picture. And the fifths are the green dots. Okay. And then we see, well, how many units away is the 7 from where we started? So there's 3 units. So in the picture, I'm starting at the square root of 4, which is 2. I'm going to go 1/5, 2/5, 3/5. And so that's what I say. I say that the square root of 7 is about 2 3/5. If I'm going to write that as a decimal, do you know the trick for fifths to turn it into decimals? Just double the top number, so that's 2.6. And that's a pretty good approximation without having a calculator for the square root of 7. So let's try a couple more of these, all right? Yeah? Try a couple more. So without the use of a calculator, let's approximate the square root of 2, 8, and 13. So let me just do, let's say the square root of, let's do the square root of 13 together. And then I'll have you do the 2 and the 8 on your own. I think you'll be able to handle it by then. Okay, so the square root of 13. I first have to figure out like what it's in between. So on the big side, I know that's the square root of 16, right, which is 4. That's the perfect square that's on the big side. On the small side, the perfect square would be 9, which is 3. So it's in between 3 and 4. Okay. So now I figure out how many little units does that break the number line up into. So from 9 to 16, that's 7. That's 7 units. And then from 9 to 13, I've gone 4. Yeah, there we go, 4. So I'm going to approximate the square root of 13 as, wait, maybe I should like write this a little tidier. So keep it right over here. The square root of 13 is approximately, that's 3, because the square root of 9, and 4/7. Now, I don't know my sevenths. I don't know a trick for sevenths. So if you wanted to leave it as 3 and 4/7, you're perfectly okay with that. So I'm going to say that's the approximation. So I want you to give the square root of 2 and the square root of 8 a try on those. And pause the video and then come back and we'll check your answer, okay? All right, you're back, right? And so let's see how you did. Magic. Okay, so let me suggest that if you're having a little bit of trouble with this, maybe just draw yourself a little picture of a number line or something like that. Maybe it'll help you. So we're approximating the square root of 2. So we first figure out what perfect square is it in between. So we got the square root of 1, which is 1, and the square root of 4, which is 2. So it's got to be in between 1 and 2. Okay, and then I see how do I break up all of those square roots? Between 1 and 4, right, look at it, between 1 and 4, there are 1, 2, 3 intervals. How do I get that? Like, if I didn't want to draw it, how could I get it? Well, you just subtract 4 minus 1, and you get your 3. That's how many I would, how many intervals I would need. And then I figure out, like, where's 2? How many intervals is that? It's just one of them, right? Again, I could get that from looking at the picture. It's 1 away from the square root of 1. Or I can look just by subtraction. 2 minus 1 is 1. So approximate it as 1 1/3, 1.3333 or whatever. And that one's actually off by quite a bit because it's really 1.4. Hey, that's all right. I'll be with you in a minute. Okay. And then finally, the square root of 8. The square root of 8 is between square root of 4 and the square root of 9. So we got 2 and 3. And then again, just break it up. Maybe you don't need a full diagram of like the whole entire number line. Why don't you just go, oh, from 4 to 8, that's 4 of them. And from 4 to 9, that's 5, 4/5. 4/5 is double it, so it's 0.8, 2.8-ish. Okay, so that'll wrap up this objective. Now, that doesn't mean you're all completely done. There's still a few more exercises. Check those things out in the next video.